everyone, welcome to today's event. My name is Leah Moon. I'm with the Esko North American marketing team. Wanted to go over a few housekeeping items before we get started today. All participants are muted to avoid unnecessary background noise. If you'd like to ask a question, please use the questions tab on the right-hand side of your screen. You will also notice that there is a polls tab. I will be issuing a poll about halfway through the event, so if you guys could please answer the question, that would be great. The webinar is being recorded. You will automatically receive an email with a link to the recording after the webinar. If you're having audio and video issues, I would like to remind you that this presentation is through your browser. Please refresh your browser to resolve any issues and remember to increase your computer's volume. There is an option for a dial-in number. If you click on the help button that's in the upper right-hand corner, there should be a phone dial-in that you can use for this event. I would also like to call out that today is day 1 of a 2-day event. You were automatically registered for day 2, which is tomorrow at the same time, 1 p.m. Eastern. If you did not receive an email for day 2, please let us know at info.usa@esco.com, and I will make sure to get your link over to you. And without further ado, we'll have Rory Marsoon get it started for Esko. Rory?
All right, thanks a lot, Leah, sorry. Yep, my name is Rory Marsoon, and I am the Director of Business Development for Flexo at Esko. And just a quick introduction to me. I've been with Esko for about 10 years, been in the industry for about 16 years at this point. Started my career at Clemson University as a faculty member, did a lot of testing research, taught some students and all those good things, and moved to Esko in 2010, where I've had a bunch of different roles, mostly technical roles, and still today I'm very much a Flexo geek at heart, and very excited to come today and talk to you about some fantastic Esko and DuPont solutions that we'd like to offer you. Having said that, I'd like to give Ali a moment to introduce herself.
Thank you, Rory. My name is Ayers. I'm a technical application specialist with DuPont Image Solutions. Basically, we help implement new products for their Flexo plates. We also help problem solve, and also we help with quality control. Basically, anywhere a customer needs us and anything they need us to do revolving around Flexo plates or plates on press, it's kind of where we come in as technical application specialists. So.
Yep, thanks, Ali. So if this is the second week of a 3-week series, last week we covered labels, this week we're covering flexible packaging, and next week we're covering corrugated. There are some similarities with some pretty significant differences. So if you attended last week, you'll see some of the same information, but don't worry, there's plenty of new information in here as well to address this particular market. As Ali and I kind of decided how we were going to present this and what are some of the things that we're going to talk about, we thought it was important that we start with kind of, the flexible packaging printer in mind, and what is it that you guys care about in that marketplace. And this is obviously from our perspective, but obviously we talk to a lot of customers and we try to understand what it is that you guys are looking for. So we've tried to summarize here what are the key things. So number one seems to be quality. This varies from customer to customer, but it seems like the common denominator is you have to have good quality, particularly if you're looking at newer solutions. That's usually kind of just a given. You must have the best quality. Turnaround time with all the different pressures that are on all of us in the industry to take a package from concept to final package to the store shelf as quickly as possible. Part of that is getting plates to the press quickly. Super fast make ready. So once the plates get on press, what we're hearing is that you really just want to put the plates on there and get printing as fast as possible and not have to mess around with impression settings and getting the color correct and all these things. That seems to be a major desire for a lot of printers. Consistent and repeatable, this is a big one where, if you do something today, you need to be able to do the same thing tomorrow and a year from now, or even longer. So we totally understand that, and we're talking about some of our solutions that address that. And then, of course, environmentally conscious. So, it's all nice to have a product that's great quality and all these other things, but if it's not good for the environment, then we have to ask ourselves if it's worth it. So this is also a big factor that both of our companies like to focus on. So we'll come back to these at the end of this session, and we'll just talk about how we feel our solutions are answering these needs for our customers. So when we look at the product offering and the plate making workflow that we have, we really boil it down to some very basic steps. Ripping and screening is really where it starts. You have to have a file with all the dots and special screening in that file before you can even start to make a plate. And we've got some pretty cool solutions there. So we're going to be talking about screening first, and then go to imaging and exposure, and then moving into the processing part of the plate making process as well. But the one thing that is kind of a constant throughout all this is the plate itself. So that's actually where we're going to start our session today, is with giving Allie an opportunity to talk about their plate offering. So with that, I'll hand it over to Allie.
Thanks, Rory. There's a lot of times people ask us what is the best plate, and really that's a hard question to answer because there are so many different plates and there's so many different variables within Flexo. So what might be good for one customer may not be the right solution for another customer. But you can go to the next slide. So really, it boils down to a few factors, but what I'm really going to focus on today is our flat top dot plate technology. So flat top dots typically can provide a higher consistency in print. You have to think about the top of the dot is flat, almost like a cone shape. So when you set the correct impression, it holds finer details. You have the ability to, thanks to Esko's and their screening capabilities, engrave a microcell pattern. Which can help your highlights, your fades to zero, your transitions, and also in your midtones, and have a better solid ink density. Whereas the round top dot, you can hold a smaller highlight dot if you have set impression correctly. But often we know that in a trial, you'll have the most perfect impression and everything will go great. But as soon as you put it into real world application, that impression isn't easy to hold all the time. You can go to the next slide. So with a round top dot, you can also often what you'll find is a strong amount of dot gain. There will be dot bridging, which will cause some dirty print. With the flat top dot, we find that it allows you to hold a microcell pattern because you can actually engrave on the top of the dot, which can give you higher ink transfer, solid ink density, smoother ink laydown. It also comes up to color a lot faster, and it reduces the model in paper, which is very important. Go to the next slide. So right here, you can see that with the in a wide web flexible packaging and printing application, you can actually increase the surface area of the dot by creating a texture on top of the plate using, let's say, microcell. So by putting a pattern on the plate, you allow more channels for the ink to actually flow through, and therefore it gives you a smoother ink laydown. These are actually two applications of a real life print on the left and the right. So you can go to the next slide. So with this, you can see with our plates, we have the engineered surface, and then we also have the smooth plate surface. So to get that textured surface, you You can either have it built into the plate, which is what our engineered surface plates are. They have a technology that allows the plate to be a little bit textured on top, or you can actually engrave onto a smooth surface with microcell patterning, or other different textured patternings, which I believe Roy will be going into a little bit, into a little more detail of that later. But the Cyrel Easy plates allow you to do that because unlike the round top dot, which is formed and it has a round, quite literally has a round top, the flat top actually allows you to have a lot more flexibility in what you engrave on the surface. Go to the next slide. Thank you. So here's a side-by-side of the standard digital plates and the Cyrel Easy plates. You can see on the right side that there is not a lot of pinholing. It's not as smooth of a lay down. The ink kind of has, you can see all that gapping. That could actually cause issues when it comes to scanning a barcode because it could read the barcode incorrectly. So with that Easy plates using a either an engineered surface or that microcell on the flat top dot, you can really create a smooth ink laydown, which is extremely important, especially in wide web applications. Go to the next. So the flat top dot, it has, in the flat top dot technology, and most specifically what I'm going to be talking about today is the Efx Plate. Our Efx Plate is a medium hard durometer plate. It's a fast plate, which means you don't have to run it through solvent. You can have a quick turnaround. You can really hold fine details well due to that harder durometer, but you can also have good ink lay down on even paper or any polymer substrate, which it makes it very versatile. It also it works with UV inks, solvent inks, pretty much every ink, and water-based ink. So it has a simplified workflow, so it has much higher productivity. It's consistent because of the flat top dot. You don't have as much dot gain. It comes up to color, and that kind of reduces you have reduced errors. And there's a lot of plate-to-plate consistency, which I said earlier. The quality and performance compared to a digital round top dot, you have a higher ink transfer and color saturation, and then it really does improve those midtones and highlights, like I was just saying. And then on the press performance, you can print consistently across many different presses, which is really nice. And then we have higher press speeds and higher durability on press. So.
Okay, thanks a lot, Allie. So at this point, we're going to switch gears and go into our screening. And, Esko's got a long history of screening, from different acquisitions we've had, going back more than 20 years. We've had all kinds of unique screening technologies to address the needs of the marketplace. And we have just recently, in the last couple of years, come out with our newest generation of screening. And so that's really where we're going to focus today. But before we do that, let's talk about kind of where we've come from. So, when we optimize a plate and screening and curves and all these things, it's kind of really a delicate process. It's one of those things where if you kind of select the wrong dot, or you set the wrong min dot, or you set up the curve wrong, it could have truly devastating effects on press. For example, the dots could start wearing off if they're too small, or getting dirty, or if the curve is wrong, your color is going to be wrong. These are important things, and we have to acknowledge that it takes a certain skill level to do that. Now, in the past, we've had tools, and some of these tools we still sell today. A lot of our customers still use them today. So I'm not knocking them, but I'm trying to explain kind of the evolution that we've gone through here. The first real tool that we put out in the marketplace to optimize screening was called Screen Manager. And it is not a simple program, let's just be honest. You can do lots of things with it. You can build infinite numbers of different types of screens with different dot sizes and different levels of randomization and different solid screenings and all these things. But the truth of the matter is this was actually originally an R&D tool used by, kind of developers to build new screens. And we decided to sell this product to our customers. And the problem here is that you really, really have to be an expert. And it requires a lot of training, maybe in some cases, some consulting services to really utilize it. So while some customers really love it, it was kind of out of reach for so many other customers. And that's where we brought HD Flexo to the table. HD Flexo was released in the year 2009. So it's been 11 years now, which is hard to believe. Thousands of customers running HD Flexo today. And this basically took the screen manager concept and simplified it, where you just select your plate that you're going to use. You can say, okay, it's flexible packaging or it's labels or whatever it is. And it would generate a target that you would print, and then you do your analysis and select the screening. That really started out very simple, but what happens over time, as we all know, is there's new plate materials. At that time, it was mostly a round top world. We transitioned into a flat top world, which it caused this big explosion of different microcell patterns and highlight dot technologies and things like that. And so what happened is this thing became so full of different screening technology that it was, once again, too complicated. This is an example of a target that's generated out of HD Flexo. The number of variables on this target is in the hundreds. Different solid screenings, different different solid screenings, different highlight technologies, different curves, things like that. And so it takes a real expert to analyze this. And I'm not saying there's not people out there that can do it. It's just, it takes time and it takes the right type of person and expertise level. So, there's a lot of visual analysis, which is subjective. All right. When I look at this target, I'm going to say, you know what, that dot right there looks the best, and I think I would pick that one. Whereas this person over here might say, you know what, I'm going to pick a bigger dot because I know it's going to be more robust on the press. And so we've done studies where we ask different experts to pick different, what do you think is the best screening? And you pretty much get a different answer for every person. And that's a problem. Then you have the, a lot of analysis with measurement. So you have visual and measurement analysis. So maybe you're going to measure to see what's the best highlight dot. Then you're going to go to press. At that point, once you've selected your screen, and run a fingerprint to determine your dot gain curve. Maybe you're doing G7, you develop curves that way with a P2P target or something like that. But there's many steps in this process, and it does require a high level of expertise. Again, this is a manual curve creation, right? I don't know about you guys, but I love making curves. But I also know that it takes time, and it's also very easy to mess up. And as a person who's looked at a lot of curves, I can tell you that there's a lot of bad curves out there, and they have a negative impact on press. So the solution we've released now is called Print Control Wizard. It is an automated tool that is designed to simplify the process of implementing screens and curves for Flexo, which speeds the whole process up. And at the end of the day, it's going to cost less because you're spending less time. Maybe you're going to optimize. You're more likely to go through the optimization process for every different variable because it's simpler. And it also contains our very latest screening technology. Okay, so this is just a couple images from Mark Samworth, who, by the way, I'm just touching on Print Control Wizard today. Mark Samworth is going to really go deeper into the print control wizard and also into the XPS tomorrow afternoon. So if you're interested in this, you might want to think about returning for his session tomorrow. But you can see here, we're measuring the target with an I1IO. So it's very quick, very easy. The software analyzes that. It'll tell you what curve you should use, and it tells you what screening technology is best for you, given your printing conditions. So crystal screening is what we are calling the screens that are generated by Print Control Wizard. Most of the screens are different from the screens that we had in HD Flexo. There are some screens that are very similar, depending on the application. But flexible packaging is really one of those areas where the screening technology is very different and very unique compared to what we've had in the past. So we do have flexible packaging, and we've just recently added some new white ink screens into that package as well. We have a labels version, and coming in November, we will have a corrugated version of Print Control Wizard as well. So this is just an image of a mid-tone dot with and without crystal screening. So when we talk about the benefits of crystal screening, most of the time we're going to be talking about cleaner printing dots. We're going to be talking about better consistency, just overall sharper dots. You can see that not only are the dots there's less dot gain, but they're sharper, cleaner. They're actually closer to the desired size. And the color is very, very even across the entire dot versus a standard Flexo dot where you're going to have kind of thicker and thinner ink film thicknesses throughout the dot. This leads to a much higher level of consistency and much cleaner printing. This is an example of a very common flexible packaging issue that we see, particularly with flat top dots, where we have this band that occurs in, you often see it in vignettes, which is actually caused by dot bridging. It's dirty print. That is oftentimes completely eliminated by the crystal screening, right? So it again results in much cleaner printing. We have customers tell us, we're not stopping to clean the press nearly as often as we used to because the screening allows the plate to print cleaner for longer. This is a process color image under magnification from one of our customers who sent this to us. They were super excited to see, just the sharpness, the cleanliness. You don't have the muddiness in the image, the sloppiness in the dots that we typically would have. So it's very easy to see there. And I'm going to show just a couple images from a print sample that we printed for the FTA forum last year. So some of you may have seen this sample in person, and maybe you have the sample. You could take a look. But these images were actually split in half. So some of them, not all of them, but like the berries here, the feathers, and the popcorn were all split in half. And you've got legacy screening, which is really HD Flexo with WSI. So it's a very common screen that most people are using. And the other half was crystal screening. And you can very clearly see the difference. Once you look under a microscope at the dots, you see exactly what I've already shown you, which is just a sharper, cleaner dot. We saw that the dot gain for crystal screening was about 12% less, which means you can use a less aggressive curve, which means you're going to have better overall detail. Your highlights are going to be less grainy, and it's going to be just a better quality image overall. One other key thing is in the highlights, we're able to print smaller dots, and actually the screening technology is designed to reduce, minimize the graininess. So if you've ever tried to use HD screening in the highlights, you may have seen some of this graininess that we're seeing here. And I chose the popcorn image on purpose just to show that. we're able to use smaller highlight dots, and we actually, when we build the curve with Print Control Wizard, we actually build it in such a way that it tries to minimize that kind of randomized area that looks grainy. So we have a lot of customers that say, it really helps in this area, and especially when you start to combine the screening with the XPS, then we'll even see more benefits with being able to hold smaller dots and things like that. And again, this is showing the same type of smoothness in the vignette. So very interesting. And as I said before, the new version 20, which was released maybe 2 months ago, does contain some white screening. All right. And white screening, we're going to talk quite a bit about this, and Ali is actually going to jump in and share a little bit about white screening as well. But for those of you who print flexible packaging, you know the importance of a good white ink laydown. It helps with the appearance. It helps with, kind of hiding the product that's behind the packaging and those sorts of things. So a lot of folks are very interested in improving that white ink laydown. And we have several different screening technologies built into Print Control Wizard, and also DuPont has the Easy Bright screens, which is kind of trying to reach the same goal and increasing opacity, giving a better quality white. This is actually an image of the Print Control Wizard target. And all it really is just different patterns, and it allows the user to look at the patterns and analyze that and pick the one that's giving the best result. And then once you designate that, it'll begin putting that white behind all of your other targets and loading it and building the screen and putting it in the rip for you. With that, I'm going to hand it over to Ali. She's going to talk a little bit more about white ink.
All right, thank you. So basically, Marie, if you want to go ahead and go to the next slide. So oftentimes we always judge white by opacity. That's the standard in the industry. You just look at the opacity. If it's a high opacity, then that's what people think is good. But it's not always just about opacity. If you see here, the image on the left and the image on the right have the exact same opacity. And if you'll go click next, Rory. So one more time, you can go to the next slide. So if you see here, like the left and the right, they have the same opacity, but when you add blue or a cyan or a yellow or magenta over top of that, which Rory, if you could just, there you go, you can see that it definitely changes how it looks when it's actually applied or when the ink is laid down. So DuPont kind of came up with what we call this Easy Bright Index, where we said, you know what, we don't just measure color with one spectrum, which if you go to the next slide. So when you're measuring color, if you use a densitometer, it only measures one parameter. So then you see these 5 pink swatches. They all have the same density of 1.35. But if you are looking for the middle swatch, and then you've got the one to the right of that or the left of that, the customer is not going to be happy. So that's where they came up with the LIB color space, where you can measure with a spectrophotometer, and you can get a more holistic 3-dimensional measurement. So that way you can really narrow in on color. So we kind of said, why can't we do that with white? And what we ended up coming up with is opacity as well as graininess and model. So graininess is the smaller pinholing. It's kind of what you saw in that first photo that I was showing, the 2 opacities. It's where you can really see some of the whatever is behind what is laid down on that white ink. And then the model is the larger voids, the big imperfections. We measure both of these with either a QEA meter, and then the model we measure with a QEA meter or a Betaflex. So basically we want to reduce graininess in model and increase the opacity, so that way we can get a holistic white assessment and really have a pure good white. Go to the next slide. So here you can see a little bit about what I'm speaking on in the modeling, which is the model is where you really take a grand scheme when you're measuring. You're looking at the bigger picture, whereas graininess, you're looking at those micro imperfections. You can go to the next slide. So what we did, like I just said, we're making an easy bright index, which is a function of opacity, graininess, and model. It's multidimensional. That way we can really understand and communicate white in an easy way. The higher number of this easy bright index, the better of the white. So it's really that easy. You can go to the next. So if you can see here on the left, this is an unscreened white. Rory kind of mentioned the two different white methods, or the two different types of white screenings that are out there right now. So on the left, we did not screen the white. We measured the opacity, and if you can see, the opacity from the unscreened and the screened are very similar. However, the graininess was a 2.3. So that graininess gave us an easy bright index of 25. Whereas on the screened, we got a graininess of 0.9, which achieved a easy bright index of 65.4. So again, if you remember back to that slide where we added the cyan ink laydown, if you put a cyan ink laydown over the screened versus the unscreened, you're going to get a much more vibrant blue. It's really going to stand out. It's going to block out whatever is behind, and it's going to give you a really solid, nice white. Go to the next slide. So one thing that is very important to remember is that when you are using these easy bright, or you're using a white screening, you want to make sure you have a medium or high analogs for flexible packaging. This is where you're going to see the most improvement. It's important that you remember that it's not just opacity. We're really trying to change that mindset that opacity is the only thing that matters. You really need to take a deeper look. You can actually even just hold up the white substrates to the light and look at it, and you can see how much pinholing there is without the screening. You don't need to use a QEA, but that really just quantifies the number. And also there's potential for higher ink savings. So instead of doing a double ink laydown or a double pass, you can achieve the same opacity, the same easy bright index with just one pass using screening methods. So really we just want the easy bright index to kind of help people understand how to like see white and change how they see white. So that way we can achieve a better white laydown. Go to the next slide.
All right. So moving into the next section here, we're going to talk about imaging and exposure. And, you know, this is really where Esko's kind of made our name in the industry, particularly the Flexo industry, with our imaging technology. A lot of people don't realize, though, that the first CDI, which was released at Drupa in 1995, was a collaborative effort between Esko, or at that time it was Basel Scheel, which then through a series of different name changes, acquisitions, et cetera, became Esko, and DuPont. So, you know, the two teams kind of came together. DuPont really focused on the mask technology, and Esko really focused on the laser technology. CDI stands for Cyrel Digital Imager, and Cyrel obviously being the DuPont photopolymer plate technology. So in '95, that was released. And over the last 25 years, we have now sold very close to 4,000 units of CDIs. So it's very exciting to kind of look back on this now and watch the progression of that story, because the technology that we released in '95, while fundamentally is the same concept, we're using a laser to ablate a carbon mask on a plate, the technology behind that has evolved quite a lot. In the year 2000, we came out with fiber laser technology. We didn't invent the fiber laser, but we implemented that in Flexo plate imaging for the first time. And then we saw improvements with resolution, you know, being able to image at 4,000 DPI. We actually have some specialty applications where we're now at 10,000 DPI or maybe even higher in some cases. So very, very high resolution imaging. And then we start getting into the concept of LED exposure. So you see here, our very first LED exposure system was in 2008. So when we talk about the XPS in a few minutes, recognize that it's not the first time we used LEDs to expose a plate. There's a lot of learning and history that went into that technology. HD Flexo and full HD Flexo, those are technologies that included screening combined with high resolution imaging. In the case of full HD, we had inline UV exposure technology, which again was LED, combined with the certain screens and technology there. And in 2016, we launched our Crystal platform, and then just a couple of years ago, we launched the Print Control Wizard. So it's been a nice progression, and we like to think that some of these technologies have really changed the world of Flexo for the better in terms of higher quality, better efficiency, and all those very important factors. So if we kind of look at our product offering for CDIs, we have two major families. One is the Spark family, and we would call this our legacy products. The Spark CDI is just a workhorse machine, very robust, never quits type machine, and comes in many different sizes for all the different markets and needs of our customers. So we've got small machines for the label and narrow web market, medium-sized machines and large machines for flexible packaging and corrugated. And we even have a couple machines to do, imaging in the round for sleeves. And then in 2016, of course, as I mentioned, we launched our Crystal product line. So for CDIs, we have now the CDI Crystal. And you can see here, it obviously looks very different. It's got a completely new design. It uses a touchscreen interface. It's really all built around ease of use, simplicity, and also automation. So the CDI Crystal all by itself, as a standalone system, will automate the loading and unloading of the Flexo plate. You'll see here in a little bit how when we start to connect other pieces to it, it becomes a piece of a much larger automated system. Currently, the CDI Crystal is available in the 5080 and the 4835. The 4260 will be the next size, and we're looking at that being in the, I would say, near future. And also for the XPS, we will also have a 4260 as the next size. So let's talk just a bit about the XPS, which is part of the Crystal platform. The XPS is an exposure unit. It exposes the face and the back of the plate simultaneously. So if we look at this image here, we see the green box. We'll call that the UV head. Inside there, there's a couple bars of diodes. So hundreds of diodes inside this thing that are very closely kind of packed in. And that is what we use to expose the plate. Again, Mark Samworth is going to have a session tomorrow where he really dives deep into LED and what the benefits are. I'm just going to touch that here. But fundamentally, this thing basically this head moves across the plate. So the plate stays still. The UV head moves over the plate. It'll do that multiple times. And we can use different levels of energy. We can change the speed of the head and really kind of fine tune all those things to get the best result. And of course, it uses a touchscreen interface. And one of the things we're very excited and proud about with the XPS is that when you buy the XPS, it comes with all the settings predetermined for all the different plate materials that are needed, right? So what that means is the user can just select the plate type and thickness that they're going to use. They run one test to dial in the back exposure, and then they're in production. And they can feel confident that those are the right settings for that plate. So when we talk about the XPS, it's really important to kind of think of it in terms of three key benefits. The number one benefit that we have to kind of keep reminding ourselves of is the consistency. And that's really because of the LED technology. LEDs, we know, beyond a shadow of a doubt, are much more consistent than the backlight technology we've been using for so long. The LED doesn't really degrade over time, doesn't really change. The output energy doesn't change over time. So what that means is when I hit the button to expose the plate, I'm really going to get the same plate today that I'll get tomorrow and in a year from now, or between two plants, for example. So if I have multiple plants, I can share work a lot easier because they have an XPS. So this is really the number one thing. This is really why we built the XPS, was because we felt that it was very important to give our customers the highest level of consistency. Now, that's not to say that the quality is not better, because one of the kind of prerequisites when we certify a plate and determine the settings is that the quality does need to be as good or better than the Banklight version. And 99% of the time, the quality is better. Some plates, it's much better. Other plates, it's marginally better. That's also one of the things, one of the reasons we don't talk about that as the primary benefit. Yes, it exists as a benefit, but consistency remains the primary benefit. And then it is the key to automation, meaning you'll see here in a minute, we're going to talk about automation, but none of that is possible without the XPS, right? So the XPS can function as a standalone exposure unit. And a lot of customers do that. Buy the XPS, maybe replace your existing exposure unit or use it as an additional exposure unit and just manually move the plate from the imager to the exposure unit, no problem. But with the addition of a CDI crystal, those two can be connected. And in this configuration, still not automated, but the plate can just be easily slid across the glass to the exposure unit, which customers honestly really appreciate. Not having to put that plate on a cart or some kind of table or manually move it and risk kind of kinking the plate. So it's nice to just slide it over. We do have a technology now that is available that's called the plate handler, which will automate that process. And I'm not going to talk anything more about that because we will have a video to demonstrate exactly how that works here in just a little bit. But what it does is it kind of creates an automated workflow. All right. So if we start to compare the existing plate process with a Banklight unit, with manually moving the plate and break it down, we see that there's a lot fewer touch points, right, with this automated system that we're talking about. So what it really comes down to is the operator can put the plate on the CDI, hit a button, and walk away and not have to return until it's time to move that plate to the processor. And in a normal workflow, there's a whole lot more steps that have to happen. And those are manual steps that the operator has to physically be there to do that they no longer have to do. So here's another way to look at it. Here we've broken down the process into each very small step that it takes to make a plate. And this is actually making two consecutive plates. So you see here, we've got all the small steps. Retrieve the plate, warm up the exposure frame. So this is one thing, right? With the XPS, you don't have to warm up the exposure frame. LEDs just come right up to full energy. You don't have to sit there for 2 or 3 minutes and warm up the frame before back exposure. And also consider back exposure happens simultaneously with main exposure. So it's not a separate step anymore. Wait for operator. So when you think about automation, one of the killers is in a multi-step process. After each step, you often have to wait for the operator to come back. And that may not happen immediately. It might take a few minutes because they're all over on the other side of the room doing something. They have to walk back. So we've built that into the process as well. And 2 minutes, honestly, is pretty conservative. So you can see, we'll go through the whole process. There's a lot of steps, right? And we can break that down and say, the first plate will be ready in 45 minutes. Every subsequent plate will be 25 minutes thereafter. And plates after 8 hours mean you can make 18.5 plates after 8 hours. With the new workflow, these are all the steps that are completely eliminated. So most of the manual steps in the process are eliminated. And if we really look at it, the process, first of all, visually is obviously much more simple. All the operator is doing is getting a plate, putting it on the CDI, hitting a button, and walking away. Once that plate is moved over to the exposure unit, they can then load the next plate into the processor or into the CDI. So if we look at the numbers here, the first plate's ready in 35 minutes, every subsequent plate, 22 minutes, and plates after 8 hours, 21.2. So it goes from 18.4 to 21.2. So it's about another 2.5 plates every 8 hours. And we'll be looking closer at the automation system with a video, but right now we'll pass it back to Allie and let her talk about processing.
All right, so about 20 years ago, DuPont created what we call the fast processing solution. Within processing, you have solvent processing, you have fast processing, and then some other plate manufacturers have products that work with water solvents and water wash. So what I'm going to focus on, because what we were speaking about earlier, our bullet points were quick turnaround. You want to have fast product solutions, and you don't always have that time when you're working with solvent plates or when you're working with plates. So that's why we have the fast processor. So we first started with the 1000 TD. It was a smaller unit. It was the first fast processor that removes the polymer plate to achieve relief by like thermal adhesion and removal, whereas solvent uses brushes to scrub it away. So we wanted a more environmentally friendly option and a faster option, and that's how we came up with the 1000. That evolved later into the 4260, which is a little bit larger, and kind of got rid of some of the kinks in the 1000. And then we released our 2000 TD, which kind of takes the best of both of the 1000 and the 4260 into the optimal and the best machine possible that we could create. We also have a 3000 TD, which I won't really be discussing, but it is a wide format 50 by 80 solution as well. So when you're thinking fast, you just want something that has improved quality, productivity, and agility for printers and converters, so that they can create a plate if something goes wrong on press and they need another plate fast. Go to the next slide. There we go. So this has been, the 2000 has been a really big favorite, the thermal solution. We're seeing more and more customers transfer over from solvents for sustainability reasons, also for process control. There's also, it's all in one system. So we often don't have the space. A lot of people don't want to bring their plate making in-house because of the space, and solvents revolve almost a lot of chemistry. It's a lot of mess. It's a tedious process, where the 2000 really just puts the solution all into one smaller condensed, almost like a box or machine. The only maintenance that you really have to perform is changing out the webbing, which is very simple. It takes only about 10 minutes max, 5 if you get really good at it. So there's really not as much complexity. You don't always have to have someone on site that knows about balancing solvents, or who's there to take out the plates or make sure the plates are dried properly. It takes away all of that guesswork and puts it into one easy solution. Next slide. So as I was saying, we've been in the fast industry for more than 20 years. We already have over 1,500 processors installed globally in over 80 countries, which is really cool. It's very expansive. And then so far, I think we have over 100 Cyrel Fast 2000 units installed since we first launched. So we really are taking over the solvent industry, or taking over some of the solvent industry and converting some of that solvent into fast. Go to the next. So sustainability, this is a big thing today. I feel like this has been a keyword, and it's very important. It's at the core of what we do, from reducing our operational footprint and creating a market-facing sustainable solution to addressing the global challenges of the future. This is something DuPont really strives to achieve. So with solvents, you know, as I was saying, there's a lot of harmful chemicals, things that are released. It's very messy. If you go to the next slide, whereas fast kind of reduces all of that. We have 53% less greenhouse gases and up to 63% less non-renewable energy consumption. There's practically no VOCs with the new 2000 TD. It's safer. There's lower emission in the work environment. I don't know if sometimes if you guys kind of get a headache after being around solvent all day. I know I do, just because I'm susceptible to migraines. If I work in the solvent room for too long, I'm like, whoa. And then it's energy efficient. And in the last 5 years, the Cyrel fast processors have helped reduce CO2 emissions equivalent to 109 million fewer miles driven by passenger vehicles. So you're going to go to the next slide. There you go. Next slide. So with the first generation thermal, that 1000 TD, we had a VOC emission drop by 98.1%. Then we had with the most recent, we had more than a 99% reduction in VOCs compared to the solvent workflow. And that's more than 76% compared to the previous thermal processors. And this is because with the new 2000, we really focused in on how much heat we are giving off. And then we also we reduce the amount of emissions that are released into the air after the processing. Keep going. So basically, like, why have a 2000 TD? Well, it has a fast turnaround. If you kink a plate, or if something goes wrong on press, or there's a quick customer change and you just want one plate, you can have it completed in only an hour. There is no drying time, again, so you can have them fast and ready. It's easy to operate. After only a day or two of training with one of our technical specialists, practically anyone could be able to operate and run the 2000. It's just that simple. There's a cost savings. There's reduced downtime, reduced waste handling. It's a solvent-free process, and it reduced energy consumption, and it's a compact design. There's just, as I said earlier, and there's just a really smaller amount of footprint. There's a smaller footprint, an environmental footprint, and it eliminates the need for solvents and is more energy efficient. Go to the next slide. All right.
All right, so as we kind of wrap up the presentation here, I mentioned earlier the different factors that we're trying to achieve for our customers here, and wanted to review, along with Ali, how we think we've met those needs. So the first one is quality. And we talk about quality, we're talking about combining DuPont Easy plate technology, the flat top dot, with the CDI, who's got a long track record of quality in the world of imaging, with high resolution imaging, crystal screening, which we talked about, and then white screening, right? So we talked about the Easy Bright Index and how we can better understand, what the best screening might be. And then on top of that, we've got the XPS, which oftentimes will increase our quality.
We have a quick turnaround time for plates. As I just mentioned, you don't really want to have a lot of downtime. If something were to go wrong on press, or if you just want to make your plates quickly, you don't want to be waiting around for that solvent ink to evaporate out of the plate. So it's important that we have a quick turnaround time to save money, be more cost efficient, and really just improve your overall quality of your plates as well.
Fast make ready. So here, a lot of that comes from the flat top dot technology, which I think is becoming more and more of just a standard in the industry. We know that you can set impression much more quickly. It doesn't have to be as precise as it used to be with round top dots. And then, better screening technology. So the crystal screening is going to enable printers to come up to color quicker on press.
Consistency and repeatability. We find that with the 2000 TD, as well as with the fast plates and with the XPS, you can really get consistent repeatable plates, which is really important, especially if you're running the same SKU over a long period of time, and you need new plates. You want them to look exactly the same. You don't want any variability in your print quality. So with this total package solution, you can really see consistency and repeatability.
And last but not least, environmentally conscious. So Ali just got finished talking about how the fast unit, drastically reduces VOCs compared to solvent, which makes a huge impact in the plate room. And then the XPS, I didn't even talk about it, but the fact that, in a traditional tube, which contains mercury, those should be treated as hazardous waste because mercury is a toxic substance that we definitely don't want to get into the water stream, the water supply and things like that. The XPS diodes don't contain anything like that and can be disposed of in just a typical landfill. So hopefully, through all this, you've been able to kind of understand what the DuPont and Esko package looks like and what the benefits are for you. At this point, we're going to go ahead and answer some questions if there are any. Go ahead and if you have a question, you haven't already submitted it, go ahead and type that into your little question box on your screen. And Ali and I will be very happy to answer those questions for you.
Okay, so let me jump in. Ali, I have one question from the audience for you. So here, you mentioned that the flat top dot does better ink transfer. Does this affect resistance when it comes to printing on corrugated kraft?
So it's a really great question. I know next week we are having a date, or that would be the third week of this seminar, and we do talk a little bit more about corrugated kraft. We don't really use our easy plates on corrugated. They can be used, but we actually have a plate that we just released called DLC, which you can use with our DigiFlow, which is nitrogen that allows a flat top dot. It's a really great corrugated plate. It holds really fine highlights, and it also has great ink laydown and density, ink density, solid ink density. So if you are looking for a flat top dot for corrugated plates, that's definitely something you can reach out, and we will give you a little bit more information on that. But as far as the easy plates, we typically use those for paper or polymer substrate.
And if I could just add, just quickly, maybe even a teaser for next week, we are going to be releasing Print Control Wizard for corrugated, which I already mentioned. And part of that is some screening technology that does address ink transfer on kind of less than ideal substrates. So getting better coverage on those substrates, maybe being able to print with lower volume analogs, that sort of thing. So I would say, and that screening only is going to work on a flat top dot. So flat top dots are really critical for that, but then combining the screening technology with that, we are seeing some benefits.
Also, yeah, we also have our Epc plate that is a corrugated flat top dot plate, which can be combined with what Rory was saying to create a really good ink transfer, great stability. So it's also another option if you don't want to go with the DigiFlow and you want that easy built-in flat top dot as well. But again, we'll be talking more about that in the next seminar, just like Rory was speaking.
Okay, thank you. There's another question from the audience. With flat top dots, do you need a softer mounting tape or a harder durometer tape for good highlight dots or process color with screens?
So part of the optimization that we do, that's part of what I do. We go in, you get a plate, you say, hey, we want to run with your EFX. We go in and we run a trial using different durometers, mounting tape durometers from medium to medium hard or even medium soft based off of what the customer already uses. So that can be 3M, that can be Tessa, that could be any of the tape providers. And And we kind of optimize what's best for you, what's best for your press, what's best with your press operators. Because there isn't, like I said, there really is not one solution. It depends on the plate and it depends on the press.
Yeah, and I'll just add again. So we, years ago, it was always, soft tape for better highlights. And that was really important because round top dots are just very fragile, right? They're very sensitive to impression. We see customers going to a harder tape in general, like I wouldn't say they're going to a very hard tape, but they've moved that direction as a whole towards a harder tape. So instead of a soft tape, we'll say that it's a medium soft tape, right? So just incrementally harder without it being an extremely hard tape is generally what we see.
Okay, thank you. Another one, can flat top dot plates and crystal screens help to achieve higher press speed?
Higher press speed. That's a good question. That's not something I personally have heard as a benefit at a customer site. What we do hear more often is that they can run longer without stopping the press to clean, which is another great benefit. But no, I haven't heard the press speed concept myself. Doesn't mean it's not true. I could very easily just say yes, but I'd rather just be honest and tell you that I haven't heard that.
Yeah.
Okay, so far these are the questions.
Okay. Thank you very much. So at this point, we're going to go ahead and show the demonstration videos. I'm going to go ahead and cue that up here. And today we're going to show first. Looked like I was trying to start. What we're going to show first is a demonstration of the Esko CDI Crystal XPS 4835. That's the combination of the CDI, the XPS, and the plate handler. Yes, it's my voice, so sorry for that. I know you've heard a lot of me, but hope you enjoy the video. And after that, we'll show the DuPont demo video, and then we'll take questions again. So go ahead and be typing questions as we go along here. Today, we are showing a demonstration of the CDI Crystal XPS 4835, which shows the combination of the CDI, XPS, and plate handler to automate the plate making process. Here we see the operator taking a plate and removing the cover sheet. You'll see where he aligns the front of the plate to the front of the CDI, and there's a pin on the left side which he will align the left side of the plate with. This makes sure that the plate is exactly in the right location for loading. Once that's finished, he selects the job on the touchscreen of the CDI, tells it to start, and is able to walk away. At this point, the machine takes over. You'll see a small door open in the front of the machine, and it will drop the plate down onto the drum. And what you really can't see here is that the clamp of the drum opens, positions itself on the plate, and closes itself, and then begins to pull the plate into the CDI, exactly how an operator would do this manually. Once the plate's pulled onto the drum, the clamp opens all the way and allows the trail edge of the plate to fall back down and under the clamp. The CDI now begins to image automatically. The CDI Crystal is equipped with the latest imaging technology, including high-res optics, which allows us to image up to 5080 DPI, HD Flexo, Pixel Plus, and the ability to image our latest screening technology, crystal screens. We've now skipped ahead, and we'll watch the machine start to unload the plate. What we don't see here is the drum is now positioning itself properly. The clamp is opening and releasing the trail edge of the plate. so that when it's time, all that has to happen is the drum has to reverse itself in the opposite direction that it did when it loaded the plate to push the plate out onto the loading table. Let's watch as this happens now. The system will now release the lead edge of the plate, exactly how a manual operator would do this. Opening the clamp, pushing the plate forward, backing the clamp up, and then closing itself back down. The last step of the process is that the small door will then shut again. Now the plate handler is going to move the plate over to the XPS. It begins this process by detecting the edges of the plate on both sides and also detects if the plate is exactly straight or not. This allows the system to accurately lift the plate regardless of the location of that plate on the table. Suction cups now very gently lift the edge of the plate and pull that plate backwards into the center of the table and the exact correct location for exposure on the XPS. The system now moves to the other edge of the plate, where it will again lift that plate and move it over to the XPS. The plate handler now repositions itself in its home position, and we will then see the XPS automatically go into the exposure cycle. Exposure on the XPS has many variables. We can control the speed of the head, the intensity of the UV light that comes out of that head, and also the number of passes that that head will make across the plate. It all depends on the type of plate material that's being used. Those settings are determined by our certification team located in Germany, who does many types of tests to determine exactly what the optimal settings are for each plate type. We are now going to speed up the video while that exposure continues. I'd like you to recognize that the operator has still not had to return back to this machine. The system loaded the plate, imaged the plate, moved the plate to the exposure system, and is now in the middle of doing main and back exposure. And again, that operator's been busy doing other things, whether it's pre-press or some other function in the plate department. We now see the operator returning back to the system to load the next plate into the machine. This can happen as soon as exposure begins. This allows a streamlined, continuous plate making process. Also notice how little time the operator must spend at that machine each time he comes back. This allows that operator, again, to be busy doing other things in the plate department. Okay, so that's the video demonstrating the CDI Crystal XPS. At this point, we'll go ahead and go straight into the DuPont video. Or Ali, I'm not sure if you wanted to introduce the video or if you'd like us just to go straight into it.
Sure, I'll just say a quick word. This is just a video on the 2000 TD, a little bit about how it works, and we'll show you a little bit firsthand about what it does. So there you go. can go ahead and start.
We're just waiting. There we go.
What is displayed in the screen is DuPont's latest new generation of solvent-free thermal plate making system, DuPont Cyrel Fast 2000 TD. The plate loading table is located on the top cover of the equipment. Operators can easily lay the plate on the top cover of the equipment and gently push the plate into the loading port with both hands. When the plate is positioned in place, the indicator light will change from green to blue. Next, the operator can select the plate type, thickness, and width on the operation panel, and then click the Start button. The automatic plate loading mechanism will start and firmly fix the plate to the front swing arm. The plate moves forward following the front swing arm and around the virtual central drum. At the same time, the equipment automatically measures the length of the plate. When the plate tail enters the equipment, the plate loading system will operate again and fix the tail to the rear swing arm of the equipment. The front and rear swing arms work together to drive the plate around the central drum. When the front swing arm carries a plate along the heated roller, the heating roller contacts the plate surface under the precise control of the servo motor. The non-woven fabric takes away the melted uncured resin. At the end of the plate, the heating roller will lift up in time and return to the standby position. We can see that after a cycle of processing, the plate lambs layer on the plate surface has been completely taken away by the non-woven fabric. On the front operation panel, the number of plate cleaning cycles and the current position of the plate are displayed in real time. When the heated roller is in contact with the plate, a small amount of resin vapor will be generated, and these vapors will be sucked away by the gas collection device located above. The built-in K-Tox catalytic unit of DuPont Cyrel Fast 2000 TD will decompose the steam at high temperature. After the printing plate is cleaned with a set number of cycles, the uncured resin has been completely taken away by the non-woven fabric. At this time, the equipment will automatically exit the cleaned plate from the machine, but the plate tail will still be fixed on the rear swing arm, waiting for the operator to remove it. The operator presses the eject button to activate the plate unloading mechanism, and the plate will be completely withdrawn from the equipment automatically. DuPont Cyrel Fast 2000 TD is environmentally friendly, efficient, and reliable system with a user-friendly interface.
Okay. At this point, do we have any questions?
Yes, we do. So for Ali, how often do the webs need changing in the 2000?
So that's a good question. It's about 14 to 15 plates per developer roll and non-woven roll. And then for the PET roll, which is in the 2000, it's about 140 to 150. The take-up roll is actually changed every time the developer roll is changed. And then to change all the rolls, PET, the developer, and heat the machine back up, it's about a 15-minute to 20-minute process.
Okay, for you, Rory, how often do you expect customers will need to replace LED diodes? Have you had any customers that needed to replace them yet?
So the diodes from the manufacturer have an expected lifetime of 5,000 hours, which is quite a bit longer than tubes, which is generally somewhere around between 500 and 800 hours. Have we had to replace any? We've not had to replace any diodes in an XPS to this point. The systems have been out there since 2016, and actually some of these systems already have 9,000 hours or more. The expected lifetime estimate from the manufacturer is certainly not like a written in stone type thing. We have a lot of these diodes out there, and even in some of our older systems, and we generally do see on average it's much longer than that. So yeah, I'd say at least 5,000 hours would be the answer to that.
Okay, thank you. Another question for you, Rory. When will the Crystal 4260 be available to purchase?
The CDI 4260 would be early part of next year is our estimate at this point. Don't hold me to that, but I think that's a pretty safe target. And the XPS is actually going to come out before that, and we're looking at actually very soon, within the next couple of weeks, we'll have that available for sale.
Okay, this is what we have for questions so far.
Okay, thank you very much. All right, so at this point, we'll hand it over to Adam, where he'll talk about pre-press software.
Okay, thank you. So give me just a moment to share my screen. Okay, so we're going to shift gears now, and we're going to move upstream quite a bit and talk about how do we get files smoothly and quickly all the way down so that you can send those files to your plate maker. So my name is Adam Toke. I'm with Esko Graphics, and I'm on the software pre-press side. So we deal with any software that's involved with preparing files, getting those files out to basically all the way to the point of sending them to the plate maker. So from receiving files from the customer, editing those files, proofing those files, and making layouts. So we're going to be touching on a few of those software topics today. And I have a couple of I have a few slides to go over, and then I'm going to show a demo video that will demonstrate the things that I'm talking about here. So first of all, what are we facing today on the software side? It really comes down to we are getting more complex files, and customers want their products faster. So that's really what we on the Esko pre-press side of things have been focusing on. So we are working on getting files fixed faster and spending less time on repetitive tasks that really do not add value to the customer. And I'm going to show a couple of those tools today. Initially, I'm going to go over just kind of an overview of the tools that I'm going to show you, and then we'll have a demo video to show it in action. So what do we have in this area? Esko has a number of editors. Our main editors are DeskPack plugins to Illustrator, and also we have a standalone PDF editor called ArtPro Plus. And these two editors are prime editors moving forward today, and they basically allow you to quickly and efficiently fix files that come in from customers and be able to get those out to press faster. What you also see on your screen right now is a couple of examples of our Studio 3D tools. So I'm able to take files and the artwork directly from Illustrator or Art Pro Plus and visualize that in 3D, including transparency effects. And so I can be able to see, say, this pouch in 3 dimensions, make sure that the art is correct when it actually gets folded up before it gets out on plate and I find that there's a problem. We have tools for fast trapping as well, and then and automated trapping, I should say. And then also tools for fully automating complete processes for output. And so we'll be looking at our automation engine software that will automate proofing and then final plate layout. So a couple of the tools we'll be looking at today, and these are not, it's not the full extent of the DeskPack tools, but I wanted to highlight some of the newer tools that we have available. So one of them is a new plugin for called Recognize Barcodes, and this will take a vectorized barcode and convert it back into a known and editable dynamic barcode in our plugins. This barcode plugin allows you to stay within Illustrator and manage all of your barcodes right there without bouncing out to other pieces of software perhaps to handle that. We have another similar solution called Recognize Text. This will take vectorized text and convert it back into live text. So oftentimes customers will send you files. They will outline those files, outline the text so that they don't have to include the fonts. But occasionally, if you need to make any edits to that text, then this recognized text would save a lot of time in retyping text in order to make corrections. Another tool is called White Underprint. This is very handy for creating white underprints, especially on various bag or pouch files. Clear substrates, definitely need to have a white ink underneath or as your base. And so we have a plugin specifically for grabbing objects in the file, merging them together and coloring them or applying a new ink for white, or in the sample I'll be showing using the same tool for doing a varnish ink as well. So it saves a lot of time in merging different objects together and makes it just a one-step process. Once again, I mentioned Studio. Studio is a very powerful 3D visualization program. This is a plugin directly to Illustrator, and it allows me to see the artwork live right within a window in Illustrator. And it will also update the artwork live as well. And so as I make changes, I'll be able to see that in 3D, make sure that things are aligning back to front, on the ends and whatnot. So very, very powerful, and also powerful for proofing either internally or externally. Another new tool that we have is a rebuilt automatic trapper. This is what we call an aesthetic trapper. It has been redesigned, and so that it will automatically trap the file, but it will also produce much smoother traps. So traps that would previously have bounced back and forth across maybe a multicolor line will basically pick one direction and trap one way the entire length of that trap. It makes for smoother traps, less noticeable traps, and also it's a very fast tool as compared to doing it by hand. In addition to that, Then we'll look at our automation engine software. Automation engine is a full-featured workflow automation tool. It's server-based, and it's very, very customizable for the type of work that you do at your business. This workflow that you're seeing here is very much like a flowchart. So the file will come in, and I can do a number of tasks on this file, and it will go through it. It's very powerful because it can utilize data, any data that's available, to make a decision based on, say, what customer this file is for, which press it's going out on. The workflow can be very flexible and be able to utilize that data as individual files go through, so that your operators spend less time doing repetitive tasks. We will see the workflow today automatically create a proof box for me, or a proof sheet, I should say, and then also automatically create the layout. Those are two areas that we oftentimes see a lot of time spent for one operator to maybe spend 20 or 30 minutes making a proof, and perhaps an equal amount of time making a layout. This is a sample of a proof that we'll see today. The automation engine software can automatically create a proof box and also populate it with the information from the incoming file, so which inks, and then any data that's inherent to the file itself, which is where those inks would come from, or say today's date, or even just data that's available anywhere on your network. I can use Automation Engine to pull other databases or other business systems and apply that information onto a proof tag. And one of the last steps is automatically creating a layout. Automation Engine can pull in source files, one-up files, do a step and repeat, add any gutters that are needed, any rotations, be able to make multiple lanes, ganging as you see here. And then it can also apply standard marks files. And so your operators don't spend time applying marks, recoloring those marks, repositioning those marks. Those things can be done automatically within the software. Really what we're focusing on here in the automation side, the back-end side of things, is to keep your operators doing the things that they do best, which is fixing the files up front, fixing the one-up, and then allowing a lot of that downstream legwork to be done automatically and saving lots and lots of time. We've seen dramatic time savings using our tools and these automated functions. So with that, I'm going to switch over to a video, and we will take a look at a demo of what this actually looks like in action. So give me one moment. So here we see that same file that I just showed in the PowerPoint. And we're going to go through and see how this file is prepped using those tools in Illustrator. Now, the tools that we're going to see today are not exhaustive of what we have available, but they are some of our newer tools. So here we have the ability to modify the inks that are in our file. It's a very common standard tool. This is not new. But it's very, very handy to be able to designate what inks are in my file and be able to tell Illustrator which inks are printing inks, which inks are opaque inks, and anything that is custom in that way. So the first thing that we're going to edit in here is we're going to come in and see what we can do with this barcode. So we have my dynamic barcodes plugin. It's just a little pop-up window. I can easily use this to create barcodes, a whole slew of barcodes, but in this case, I'm going to use it to recognize this vector barcode. This barcode has no markings on it, but I can just highlight that barcode and use the extract function, and immediately it has recognized the barcode as an EAN 8, and it's recognized what code is there. So now I can just type in a new barcode, and then I can choose to add some new characters to it. Oops, looks like the video jumped. And apply that, and it has uploaded that barcode live. That barcode stays live. I'll pause the video here a couple of times. That barcode will stay live, so if I need to come back to it at any point, then I can update that, and it remembers those settings. It's not a one-time thing. I can come back to that barcode at any point in time and update it again. So now we're going to go to the top of my file, and we're going to take a look at using the recognize text function as well. So I see that I have an error in my text here, and instead of having to send this back to the customer, I can edit it here. I can see that it's not live text, it's just outlines, but using my text recognition tool, I will be able to convert this back into live editable text. I just highlight those vectors, and it will search that vector form against the active fonts on my machine and give me a confidence level, a percentage of confidence level that it is the correct font. It allows me to also click the button there to hold and be able to compare it with the original to be able to see if it's a significant jump or not. And then I can just clean up and finish. And now that text has become live text, which I'm able to edit. I can edit the text box and come in with my text tool and be able to make my changes right here without having to rebuild the entire text part of the design. Next, we're going to take a look at the white underprint tool. This white underprint tool can be used for a number of different things, including white underprint, but in this case, I'm going to use it to add a gloss varnish to a couple of objects in this design. So I just give it an ink name and an ink color, and then it's really as simple as highlighting the objects that I want to add that gloss varnish to and clicking add. It will add, and it kind of happens really fast, so I'm going to pause it again here. It will add that ink. It will merge all of those objects together and color them in that ink, put those objects on their own layer, and put that layer on the top of the layer stack and make it overprint. So there's a number of different actions that happened by simply clicking the add button there. Now, this is something that a lot of places do by hand, but this can really save a lot of time, especially if you're dealing with complex objects or objects with vector clipping masks and whatnot. So it can be a very handy tool in that way. And once again, this can be used for adding white underprints, any type of varnish, or even double hits of inks and whatnot. And here I see that it added that layer to the very top of my layer stack. So now that I've highlighted a couple of those tools, I'm able to view this document right here within Illustrator in our Studio 3D viewer. I can rotate this around, I can put a background on it, and any modifications that I do to my live art, I can just update my viewer window and it will show those modifications. This is a very, very powerful tool. This includes this includes my substrate effects, so I can use clear substrates, opaque substrates, and then it also does ink effects. So if the ink is opaque, if it's an opaque white or an opaque colored ink, it will also render varnishes, so things that are glossy as opposed to, say, a matte varnish. Those will come up and look different as well, and can be very powerful for, especially in the pouch and bag market, once this gets folded up, to be able to show someone that, hey, this is what your artwork actually looks like, instead of just a flat sheet that we see here on the left side. Sometimes that's really powerful in the QC portion of the process as well, because it can be really difficult to explain to someone how the pouch might fold up, and maybe if two objects are supposed to align, then how they do or do not align once the folding happens. Very, very powerful tool. And this can be exported as a 3D object, or it can be exported just as a flat image as well. This export window gives me a little preview. I can change the size and export that out to be sent to either internal or external people for review. Lastly, we're going to take a look at the automatic trapper. This is a new trapping engine that we've built. So all I do is activate the trapping window, and there's a couple of areas to input the distance, some options for how I want to shape those traps, and perhaps closing small gaps in the traps, in the objects as well, so that the trapper will produce smoother traps. And once it traps the file, those traps will come in on their own layer. So this is a non-destructive trapper. And these are very high quality traps, especially in a design like this, where I have a lot of those parallel lines that are coming into different colors. The trapper will produce very smooth traps. The traps do not bounce back and forth. And basically they are much less noticeable than previous versions. So at this point, I'm going to send this file off, and I'll transition. I'll make a point of transitioning at this point. So thus far, I've been showing a couple of the tools for editing this document. These tools are not exhaustive at all. We have a significant suite of tools, desk pack tools inside Illustrator for either simply making editing the file easier, or doing things that DeskPack was never designed to do, such as variable data and some of those more advanced features. So this is not exhaustive, but it's just highlighting some of our newer tools. So now we're going to shift gears, and we're going to send this file over to our automation engine software. What you'll see here in the drop-down menu is we have a direct link from Illustrator to our automation engine server. And automation engine is our server-based workflow automation engine. So this will export the document, send it over to the server, and be able to kick off a workflow automatically. All I do is choose launch workflow from the menu. This will bring up a list of workflows that are available on the server. I have one for flexibles. And I also have a number of options. So if I need to retrap the document, I can change those options. These are all variables that I can change on the fly as I submit this document. So if I need to change how the proof is being created, what my stepping options are, those all can be changed right within this window right here. So it's a variable and customizable way of submitting documents. And then lastly, there's a RIP, and this will screen the file as the very last step, and we'll be able to see that in a moment as well. So in the background, it will save the file and it sends it over to Automation Engine. What we're seeing here is the client to Automation Engine. It's called Automation Engine Pilot. And in the lower portion of the window, we will see a workflow produce a bunch of tasks. Those are tasks that are running, and those will populate as they are completed. And this will churn through an automated workflow to automatically create my proof sheet as well as my step and repeat plate file. So right within Automation Engine, we can view the proof as it's generated. It puts it on hold. It says, hey, go look at this proof that I automatically created for you. And here you'll see that it has automatically applied a proof template. And most notably, it has automatically populated this template with available information. So this is where it has extracted inks out of the file, and it's put those in the ink area, but it's also automatically filled in text. So what the job number is, what the date, what's the dimension of the job, who the customer is, anything that's available as information either on your network or within Automation Engine or within the file, that information can be added in a dynamic way to this proof box. So this can save lots of time. I've been through customers that spend upwards of 30 or 40 minutes creating proof sheets on every single job that comes through. Secondly, we're going to see what Automation Engine did with the layout. So using that same viewer, we're going to look at a PDF of the layout file. It has automatically grabbed the file that I submitted. It has ganged it up with a secondary file, and there's a number of different ways of telling it how to do that. But you'll also note that it has applied a standard set of marks and recolored those marks over on the left side and on the right side. So I can apply almost any type of mark. These are customizable, custom mark shapes, and then I can attach them to the sheet or the plate. I'm also able to do standard QC at this point as well. I can turn on and off separations. I can measure densities, be able to zoom into high levels of magnification and make sure that this file that I'm going to send out to RIP is correct. And right within the interface here, I can send this over to my RIP and be able to screen this file. This is really the last step in the process. We're coming up to being able to send this file out to make plates. Automation Engine interfaces with what's called Imaging Engine, which is our RIP. And now this looks very similar. I'm using the same tool, except when I zoom in, I'm now able to see the individual dots on all of these separations. So the separations have been colored and merged together. And I can turn those separations on and off and be able to do any QC at this point as well. So of course, the last step would be to either approve or reject these TIFFs and then simply send them out to my TIFF catcher. And that's where we come all the way back around to where we started, which is the plating side of things. So that is the last bit of my demo today, and I'd be happy to answer some questions. I see there's some questions in the questions area here today. One question is, are these tools compatible with CorelDRAW or only Illustrator? Our DeskPack tool set is only compatible with Illustrator right now. Well, with Illustrator, that's our only plan. It's the most common editor on a third-party side of things, so that's what we've developed and what we plan to continue. Another question is, in Studio 3D, if the package is clear, can you show the actual product to see how the print looks in conjunction with the product fill? The answer to that is yes. We have other samples of this where I could have a clear bag and simply add perhaps some 3D objects into that bag. So this does take a little bit of prep as far as creating those 3D objects and placing them inside the bag. But we have a tool called Studio Toolkit, and that's one way that I can do that. We also can use 3D objects from third-party designs or third-party programs. So any Collada file we have the ability to work with. And so there's a number of different ways of doing that. But yes, we've put muffins inside of clear plastic bags. We've put grated cheese inside of cheese bags. So yes is the answer to that. Let me look over a couple of other questions. Is text recognition tool available in the package editor? I do not believe so. I don't believe that has been added to package. That's a tool that is available in Art Pro Plus and also DeskPack as a plugin, but I don't believe it's been put back into package. One more question is Esko including Digimarc barcodes in editors so I can apply these to my jobs? No, we have not done that close of an integration with them. Digimarc, for those who don't know, they make security barcodes that are embedded into images or just pattern-based barcodes. And we have a workflow integration with them that they've developed with us, but we don't have their barcodes built into our dynamic barcodes. Well, Leah, are there any other questions that I'm missing, or does anyone else?
Most of them. I haven't seen them. If you guys have any additional questions, feel free to email us at info.usa@esco.com. That is also the same email address if you happen to not receive your access link for day 2 of today's event. Mark Samworth and Corey Devlin will be joining us. Plus, we will be doing a town hall with some customers and experts in the industry. So we'd love to have you back. So just send us an email if you did not see that. And that will wrap up today's event. I don't see any more questions. So thank you to everybody who attended. Thank you to our speakers. And we will see you same time tomorrow. Thanks, everyone.